Hi, welcome to week 4. I'm going to go over homework 3 real quick. Question 1 says Charles is a 74-year-old professor. He's going to be employed. Dina is going to be unemployed. Gilberto is not in the labor force. Neha is unemployed. Lorenzo is not in the labor force. And Juanita is not in the adult population. So to ask for the labor force participation rate, we know that's going to be labor force over adult population times 100. So in the labor force, we know that the employed and the unemployed added together. So we have Charles, Dina, Neha, that's 3. So the labor force is going to be 3 divided by the adult population. So it's going to be everybody except for Juanita because she's a child. So it's going to be 5. So it's going to, and then times 100, which is going to be equal to 60%. Next, let's go to question 5 with the graph. Draw the graph real quick. We have wages, because this is a labor market, and quantity of labor. We have a supply line like so, and a demand line like so. This hits at 1200. This goes up to 24, 0. It's going to be 12. It's going to be 600. So the very first part of this question says if minimum wage is set to $21 per hour, what is the quantity supplied, demanded, unemployed? So we'll say this is 21. We'll bring it all the way across. We get these 2 points. We'll drop them down. So at this point, it's going to be 150. At this point, it's going to be 1050. So this is going to be the quantity demanded, the 150, equal to 150. Quantity supplied is going to be equal to 1050. The surplus generated is going to be the unemployment. To calculate unemployment, we're going to take the quantity supplied minus the quantity demanded. That will give us our unemployment. Which in this case, quantity supplied is 1050, quantity demanded is 150. If I subtract the 2, I'm going to get 900. Next, it asks if in this labor market a minimum wage is $9. Now, is that binding? So if I set the minimum wage right here below $12, is that binding? Well, no, because if it's set to $9, it's not going to affect anybody already at the $12 minimum wage equilibrium point. So it's not binding. If it was above the $12, that would be binding. So the next one says the minimum wage is set at $12.50. The market will not reach equilibrium. Well, that would be a binding minimum wage, and if it's binding, it can't go back to the equilibrium because it's a law. You can't just ignore the law because the market wants to go to the equilibrium point. So it's going to try to push down, but it can't. So it will not reach equilibrium. And then, so that one would be true. The first one would be false because $9 is not binding. The third one is going to be false because it causes structural unemployment, not frictional. And the last one's true. That basically covers what I wanted to go over for homework 3. Let's go over the quiz. So quiz 1, the first question says, what's the company's average cost if a company pays $35,000 to produce 700 graphing calculator? The company's cost will be $35,070 if it produces an additional graphing calculator. The company is currently producing 700 graphing calculators. So it's producing 700 and it costs $35,000. We could just divide 35,000 by 700. 35,000 divided by 700. Cross out the zeros. 7 goes into 350. It's going to be 50 times. So this is going to be our average cost. And then question 2 says if a company, same scenario, a customer is willing to pay $60 for the 701st calculator, should the company produce it and sell it? Explain. Well, no. It says the company's cost will be $35,070 if it produces an additional calculator. So for the 701st, it's going to cost $70. So this is going to be the marginal cost to produce one more. And the marginal benefit of producing that is going to be what the customer is willing to pay. He's only willing to pay $60. So the marginal cost is greater. We don't want to make that decision. We don't want to make the 701st calculator. The next question is Java Hut, a U.S. coffee retailer, buys $10 million worth of coffee beans from Colombia. It also pays $5 million for paper cups and utilities, all produced in the U.S. It sells the coffee and produces using the above inputs to U.S. consumers for $50 million. Overall, how do these expenditures affect net exports? Net exports are $10 million less than otherwise because they buy the $10 million worth of coffee beans. It also pays $5 million for the cups, but the $50 million of expenditures are included in U.S. consumption. So it kind of, overall GDP goes up. Now the next one says in 2011, a country had a real GDP of 13.89 trillion. GDP deflator of 110. In 2012, it had a nominal GDP of 7.8 trillion and a real GDP of 14.24 trillion. What is the rate of inflation? So for this, you need to calculate the GDP deflator in 2012 by taking the nominal, dividing it by the real, and then using the two GDP deflators to find the inflation rate in 2012. You should have got 13.6. In the previous two lectures, we covered a nation's income, GDP, and we also covered unemployment. This lecture, we are going to cover CPI. It is a figure that helps us distinguish costs throughout time, different costs throughout time, and how we can compare those costs and income throughout the years. Now we use the CPI to turn dollars into purchasing power. Purchasing power is what you can actually buy with your income or the money you have or a single dollar, whatever it may be. I present to you guys a question. Who has it better? Babe Ruth, in his years of playing baseball, was paid $80,000 a year, or Clayton Kershaw, who is paid $33 million today? Well, it's hard to tell because prices in Babe Ruth's time were much lower than they are today. So his purchasing power could have been equal to Clayton Kershaw, who's getting paid $33 million today. The CPI monitors the cost of living over time. When the CPI rises, families typically have to spend more to enjoy the same standard of living that they previously experienced. When we covered GDP, we said that we could calculate inflation using the GDP deflator. Well, the CPI also measures inflation, and it's the one you're more likely to see or hear on the news at night. And it better reflects goods and services bought by your typical average day consumers, households, and what have you. Now, every month, the BLS computes and reports the CPI. Let's go over how we calculate the CPI and how it compares. The BLS uses thousands of goods and prices to construct the CPI, and we're just going to use a few. So what is the CPI? Well, first, we'll just clarify that it's the Consumer Price Index. It's basically a set of items that consumers buy, and we measure the prices throughout the years. Now, there's 5 steps in computing the CPI. The first one is to fix the basket. We're going to determine what goods consumers are buying. For this example, I'm going to say we're going to buy hot dogs and we're going to buy hamburgers. To simplify the example, we're only going to buy those two things. So we have hot dogs and we have hamburgers. And those are going to be the two items we look out throughout all the years. So we've fixed the basket. That's step 1. Fix the basket. I'll write the steps on the side here. Fix the basket. Step 2 is find the prices. So I'm just going to make up a few of them, but we need to find the prices in every year. So I'm going to look at 2019, 2020, and 2021. So for the price of hot dogs in 2019, we'll just say this is going to be $1, $2, $3, and then for the hamburgers, we'll say it's going to be 2, 3, 4. Make it easy. 2, 3, 4. Now step 3 says compute the basket's cost. 3. Compute basket cost. What we need to do here is determine the quantities and the price. So the quantities should have been with the fixed baskets. We're going to say 4 hot dogs and 2 hamburgers. Yeah. So let's compute the baskets. So 2019 basket cost. So we'll take hot dogs, which was $1, multiplied by 4, because that's how many hot dogs. So this is going to be the quantity. It's going to be the price. Plus we want to add the hamburgers. So it's going to be $2 price times quantity, which is going to be 2 as well. This should give us the total basket price of $8. Let's do 20, 20. So it's going to be 2 times 4 and then 3 times 2. So it's going to be 8 plus 6. It's going to be $14. And we'll do 20, 21. It's going to be 3 times 4 plus 4 times 2. It's going to be 12 plus 8, which is going to be 20. A few things to note. This is going to be very similar to how we calculated real GDP. If you remember, with real GDP, we were interested in how quantities changed throughout the years. We wanted to know how much production was increasing. So we kept price fixed, right? Now in the CPI, what we're going to do is we're going to do the opposite. We're actually interested in how prices are changing throughout the years. So we keep the quantities fixed. So now that we have computed the basket's cost, we can now choose the base year, which is the exact same way we did it with the real GDP. That's going to be 2019 to make it easy. And then we can now calculate the CPI. So let's write the equation. We have consumer price index is equal to the price of the basket of goods and services in the current year versus over the price of the basket in the base year. So basket price current over basket price. And I'll say base for base year. And then we also are going to multiply this by 100 once we're done. Just ran out of room. So let's do that for 2019. The basket in the current year, which is going to be 2019, divided the base year, we decided it was 2019. So it's going to be 8 over 8 times 100. It's going to be equal to 100. So this is 2019 CPI. Let's do 2020, which is going to be 14 over 8 times 100. This is going to be 175, because this is 1.75. And then 2021 is going to be 20 over 8 times 100, which should be 250. Now, so that was step 4, compute the CPI. And step 5 is going to be compute inflation rate. So to compute inflation rate, well, remember we can't find the inflation rate for 2019 since it's the base year. We don't have any previous year, but it's going to be exactly how we did it with the GDP deflator. So it's going to be CPI year 2 minus CPI in year 1 divided by CPI in year 1 times 100. This will give us inflation rate of year 2. So we'll use 2020 as CPI 2, 2019 as CPI 1. CPI 2 is going to be 175 minus 100 divided by 100 times 100. So we can cross these out. This is going to be 175 minus 100. It's going to be 75%. So in the first year, we saw inflation at a 75% increase, or prices rise 75%. Let's do inflation for 21. So we are going to do the same thing. CPI in year 2, which is going to be in 2021, 250. We're going to subtract the CPI of the previous year, which is going to be 175, and divide by the previous year's CPI, which is going to be 175 times 100. This is going to be 75 divided by 175 times 100, and that gives us 43%. So in the first year, from 2019 to 2020, we had 75% inflation rate. From 2020 to 2021, we had a 43% inflation rate. What is in the basket? The Bureau of Labor Statistics surveys thousands of households, and they gather thousands of items that households buy, at what quantities, and then they check the prices throughout the years, and then they calculate the CPI for every single basket in each year, and then they calculate inflation through that. Well, they also, if you can see this pie chart, it's going to break down what our household spending is. So 42% of it goes to housing, 17% to transportation, 14% to food and beverages. Medical care is 9%, education and communication 7%, recreation 6%, apparel and other goods and services are both at 3%. The BLS works very hard to calculate the CPI and all these different items. They do it each month. But they also calculate a bunch of other indices, such as the Producer Price Index, which is the same idea for CPI, but it uses items producers typically buy rather than consumers. And since producers usually pass the costs on to consumers, it can be a good indicator of changes in the CPI or even inflation at the same time. We also have other indices not calculated by the Bureau of Labor Statistics, such as that Big Mac indices, which I always like to bring up and talk about. It's basically an index full of the costs or the price of a Big Mac in each single country where they sell Big Macs. And then they can use it as an exchange rate. Now, every indices has its problems. Even in the Big Mac one, right? In some countries, they don't like beef as much. Some countries, they don't really like McDonald's, maybe. Like in India, they're not allowed to eat as much beef because of cows being respected in their religion. So there, maybe their Big Mac price isn't really representative of the exchange rate. Well, the CPI also has its problems. It has 3 problems to consider. The first one is going to be the substitution bias. Now remember, in the CPI, we're keeping quantities consistent. They don't change throughout the years. But people don't normally... Do people buy always the same amount of things every single year? Well, what if, in our example, we say that the price of hot dogs was $20 one year. So it went from $2 to $20. Well, as a consumer, I still want to enjoy the same standard of living as before, and I want to eat just as much food as before, but maybe instead of buying hot dogs, I buy hamburgers. They're cheaper. It's $4, not $20, and I can still eat more food and fill myself up, but I don't have to pay the $20 price tag for hot dogs. I'm substituting the hot dog because it got too expensive for the hamburger. Well, this is what we would say substitution bias. The CPI doesn't allow for this because we're keeping quantities consistent. Now, this causes CPI to overstate the inflation rate because it's going to record the $20 hot dog price at four hot dogs, even though I didn't actually buy the $20 hot dog because that's too expensive. But the CPI doesn't allow for the adjustment. Now, the second problem is the introduction of new goods. When new goods are released, consumers have a wider variety to choose from, and this reduces the cost to maintain the same standard of living. Consider a time before the cell phones. When cell phones were introduced, people were significantly better off, but the CPI didn't have the cell phone in the basket. Now, for any number of dollars, they were enjoying a higher standard of living. We're not exactly sure how many dollars. And this would normally decrease the CPI, but because the basket is fixed, it will not show the decrease in CPI. So again, it overstates inflation. Now, the last problem is it does not measure quality change. If the quality of one good decreases, then you're getting a lesser good for the same price, which means you're worse off. The value of the dollar drops. However, what if the quality rises? Then you're getting a better good for the same price, and the value of the dollar increases. Well, the CPI doesn't measure quality changes. If the hamburger gets better throughout the years, you're technically enjoying a higher standard of living, maybe at the same price or a normal rate of inflation, rather than an increased cost of the quality. The Bureau of Labor Statistics tries to adjust for quality changes. Say a car improves their safety a little bit and adds a little bit more horsepower, then the Bureau also will maybe increase the price a little bit. But despite the adjustments, quality can still remain an issue. Studies suggest that there's an upward bias of around 0.5 to 1% per year in the CPI. So it's overstating inflation rate by about anywhere from 0.5% to 1%, which can be quite a bit. Now, what are the differences between the GDP deflator and the CPI? Well, the GDP deflator, if you recall, represents the overall price level of goods produced domestically, and the CPI reflects the goods and services bought by consumers. Now, an airplane would be counted into GDP, and thus the GDP deflator would account for an increase in price of airplanes. But the CPI would not include an airplane in a basket that is bought by consumers. Most consumers don't typically buy airplanes. Whereas oil is a heavily imported good, and it's reflected in the CPI because most consumers need to buy gasoline for the cars and oils also for the car. But GDP deflator would not capture this. It would only maybe capture a little bit because we do produce some oil, but we don't produce the majority of the oil. Most of it is imported. So the GDP deflator wouldn't capture the entire rate of inflation that we see in oils. Lastly, the CPI is a fixed basket where GDP deflator is all currently produced goods. Now, it's not usually an issue if prices are changed proportionally, but if certain goods are increasing more than others, it may tell a different story. Let's think of a yacht. If a yacht's prices increases drastically, well, the GDP deflator is going to capture that, even if the rest of prices aren't really changing that much. Flip that, if CPI stuff like oil is drastically increasing, then the CPI will report it and the GDP won't. So let's look at a graph in the book. It's going to show us the CPI and the GDP deflator throughout the years from 1965 to now. Well, we can see that they're mostly consistent. They mostly stay together. They report very similarly. But in 1979, we saw that the CPI shot up way above the GDP deflator. We also see maybe that's 1974, 1975. The CPI went a little bit over the GDP deflator. Well, in those years, what we saw, we had huge inflation rates in the 70s, but none more so than oil. The prices of oil shot up huge in the 70s, so that's why you would see the CPI jump and the GDP deflator not jump as much. We also need to correct economic data for the effects of inflation. Now remember Babe Ruth and Kershaw from earlier. What would Babe Ruth income be today? We'll need the CPI for each year, and we'll need his salary to figure out what he would earn in the 2018 dollars. So the price level in 2018 was 251. We also need the price level in 1931. It's going to be 15.2. And of course, we need Babe Ruth's salary, which at the time he was making $80,000, which was $5,000 more dollars than the U.S. president at the time, Herbert Hoover. What is our equation? We're going to say the amount in today's dollars I just mixed those two up. It's going to be equal to the amount in year T dollars times the price level today over the price level in year T. We have all that information. Let's just plug it in. It's going to be 80,000 times price level today is 251 over 15.2. is going to be equal to $1,321,053. So he's getting paid way less than Kershaw. A common thing you might see with this is the Hollywood box office. Something I'm sure everyone's heard of, familiar with. Well, let's consider what movie has the highest box office of all time. Domestically, it's Star Wars The Force Awakens. It earned $937 million, followed by Avatar with $761 million, and Black Panther with $700 million. But this ranking ignores an obvious and important fact: inflation. If we correct for inflation, box office receipts tell a much different story. The number one movie is now Gone with the Wind with $1.784 million, followed by the original Star Wars, $1.573 million, and then Sound of Music, $1.258 million. The Force Awakens doesn't even crack the top number 10. It's actually number 11. Well, I mean, there are other reasons for this. Back in 1939, 90 million Americans went to cinema a week. Now it's only 25 million. Why do we report numbers? Why does the Hollywood box office report numbers like this? Well, it looks better for them. If they produce a new movie and it's all of a sudden making so much money, a lot more people are going to want to see it because it's so popular, or they think it's so popular. Even if you correct for inflation, these movies aren't doing so well. They don't want to paint that picture, because if they do, then people won't go see their movies. They have a vested interest in doing box office and including prices, so that each movie that comes out throughout the years is just doing better and better and better, and it'll always eventually have a new highest box office movie out there in cinema you could go see. Now, different regions have different prices. Each state has a different level to maintain the same standard of living. The U.S. average is, we'll say right here at 100. We'll rate it at 100. And then the more popular states or more touristy areas, they're going to have a higher standard of living because there's more demand there. So the prices are going to be higher. So we'll see Hawaii up there, D.C., New York, California, New Jersey, Maryland, so on. And at the bottom, we have Mississippi, Alabama, Arkansas, some of the states that people don't visit as much, or there isn't a high population in. States can correct for these by using these numbers. We can adjust our rates or our economic data for state differences. Another way to do it is called indexation. Now, an indexation is when a law or a contract accounts for some measures of a specific index. It could be any index, could be the producer price index, the CPI, could be GDP Deflator, could also be the Big Mac index, just whatever index is on the contract and the law. And this is usually in a situation where it's a long-standing contract throughout the years, and the dollar needs to be automatically corrected for changes in the price level, and they'll usually determine the changes in the price as the indexed amount for inflation. So for workers and unions, they'll usually have something in their contract that says, oh, we want our pay adjusted for inflation so that we can maintain our same standard of living. They'll have the CPI index, so when the CPI raises by a certain amount, then their wage will also raise by the same amount, and that'll be stipulated in the contract. We also need to correct interest rate. The interest rate when you go to a bank and you deposit money, they give you some sort of interest rate on your deposit. Well, let's say you deposit $1,000 in the bank and it gives you a 10% interest rate. After a year, you'll withdraw $1,100. Are you $100 richer? Yes, you are, but no, you're also not. Because what else changed in that 1 year? Prices. And what does she really care about? Does she actually care about having an additional $100? Maybe she has some sentimental reason for having an extra $100, but what she really cares about is what she can buy with the $100, what her purchasing power is. If her purchasing power changed in the last year, then that $100 isn't going to mean as much as it did a year ago. If inflation raised 12%, then she actually lost money because the inflation rate is 2% higher than the interest rate. So should she have even put money in the bank? No, she should have just spent the money, not put in the bank. But if the inflation rate is less than the interest rate, well, maybe she did earn some amount of money, but it's definitely not 10%. If the inflation rate was 4%, then she actually only made 6% interest rate. This leads us to our equation here. We have our real interest rate going to be equal to the nominal interest rate, which is the interest rate you might see at a bank. It's the 10% that they say they'll return on your deposit, minus the inflation rate. We can look at how nominal and real interest rate have changed over time as well. The book has a graph. It's in the PowerPoints. This one's, of course, they're going to trend together because it's just a subtraction. So it should really just be a certain distance away. But they should follow basically the same trend. Real interest rate is much lower than the nominal interest rate. When the real interest rate is negative, that means inflation was greater than the nominal interest rate. So in these years, the nominal interest rate was 4%, and the inflation rate was maybe, or I guess this might have been like 5%, but the inflation rate must have been 7 or 8% to make it negative. Again, this is because in the 70s we had really high inflation rate no one really foresaw, and their nominal interest rates didn't keep up. And then eventually, when they realized that the inflation rate was really high, the nominal interest rate shot up so that people would start depositing more into the banks. Because if the inflation rate is greater than the nominal interest rate, you don't have a reason to put money into a bank because it's going to slowly disappear. You might as well just spend it, hopefully make more money when money is worth more. This covers Lecture 4. We looked at overall price levels of the CPI, how it relates to GDP deflator, what are its shortcomings. We also learned how we correct for inflation on certain economic variables or economic situations like contracts or laws. We now have some more macroeconomic understanding of these variables, and going forward we can look more into savings, investment, and interest rate. But for now, that's all.